Okay, so yesterday we just introduced to the concept of database, right? And we said that, first half of our training, okay, is on around OLTP, and then we'll get into warehousing concept and data mining concept later. Okay, first let's focus on the OLTP concept itself. And if you look at the role here, okay, from the OLTP concept I'm talking about, okay, then on OLAP you have data warehousing, data mining, business intelligence, data analytics, those kind of roles. But from OLTP perspective, okay, we have three types of roles, as a database expert. Okay, first role is called DBA. So these are database administrators. Okay, their main job is about installation, making sure that database is up and running, 24/7. Okay, there is no, there are other techniques that we get into when I say make sure that, database is up and running 24/7. There are techniques, right? That fault tolerance and what happens when database crashes. It should still be able to capture information, backup, restore. Okay, so all those concepts that comes into administration. That is not our topic for discussion. We'll not get into that. Then comes database design.
Swapnil,
Yes.
sorry, but I don't see anything on your screen. It's just black.
Oh, let me know. I've just refreshed it.
Oh, oh yeah, yeah, now I can see it.
Okay, thanks. Okay, so yeah,
Thank you.
no problem. So the second type of role is called database design or database developer. Okay, um, the main job of this person or this team is to know how many tables to create, and we'll talk about database objects in few minutes. Okay, we'll discuss about the roles and then we get into that. So how many tables to create, each table will have how many columns, what should be the nature of those columns, okay, how to create, or how many views to create, things like that, which is more about the structural, part of it. And then the third is DB user, or sometimes even you call them programmers. Okay, but these are mostly about running those SQL queries. Okay, now we will be focusing on these two aspects. Okay, now when you are let's say if your role is into non-SQL kind of role, right, then you will be obviously using this. So this part is very important. Okay, how to run queries and things like that. But if your role is hardcore database engineer kind of role, then you need to know a little bit of this. Okay, so what we have done is in machine learning course that we have designed, we have not included design. We focus only on queries. And the data analytics course that we have designed, we include database design, right? So we will be covering both these topics. Okay, this is not part of our curriculum. Again, there's a different role altogether if you want to become a DBA role. Okay, so so first we'll focus on design, then we'll get into running queries. Now, when I talk about design, what do you mean with it? What all things can you design, right? So first of all that comes to our mind is obviously the database table, right? So what is the database table?
Like it contains data, like
Correct.
In form of tuples and rows, when
Right.
we systematically represent data in like structure data in form of table and sorry, rows and tuples.
Columns, yeah. So as you said, correct. Okay, so the first the main database object is tables, and this is where all the data is stored. Now this is a logical design. Okay, So again, we talk about physical design, logical design. Physical design is what DBA would be more interested in. How many files are created, where is the file saved, which file is growing, which file should be backed up, things like what happens if the file gets corrupted, the physical aspect of it, right? How many types of files are there? What are different extensions? Okay. Now we're not getting to that. We're talking about the logical perspective. Okay. So logically, data is stored in table format, right? And so as you said, yes, you have rows and columns, okay, or your tuple and records, right? You have cell, right? Cell is where your tuple and record meet, okay? And these contain, okay, unique information which we are generally interested in, okay? We are not interested in whole table. We'll be interested in this combination. What was how many runs Sachin scored, right? So table could be batsman, there could be multiple columns, multiple rows, right? But we are interested in column run and record Sachin, right? How many runs Sachin scored, right? So that's the unique cell, right? And that gives us information. Now, in fact, instead of calling information, probably data would be the right word, because the way you present this data becomes information, right? So table will give you, or database will give you the data, right? Now, how you interpret, how do you put it in your business? How do you extrapolate? Sometimes you have to build your business case on top of it. That becomes information. So information is a much larger frame than data. But of course, the basis, okay, the foundation on which you build your information has to be data. They'll ask you on what basis you are saying this, right? On what basis you are saying that Sachin is the best batsman, right? Then you'll say, see, look at the record, right? Look at the run score, look at the average, look at the strike rate. So these are the data, okay, which you need to collect to build your story that he is the best batsman. Now, he's the best batsman, people will um, contradict you, right? People will will can oppose you. But when you show this data, right, nobody can oppose data, right? Because data is data, right? It's not it's not a interpretation, right? Interpretation, people can question your interpretation, but they can't. So you have to justify. That's why in data visualization, which we will cover towards the end, of course, is about presentation, story presentation. Okay, you need to be storyteller. To be successful as a data scientist or as a data analyst, you need to create that story which people will believe. Okay, now sometimes if you have a great skill, you can even confuse people, right? You can you can fudge, or you can manipulate data and present the story. People does, okay, people does, and people who can do that are the ones who are great storyteller, right? So you need to build up that. Okay, you have to build because see, you can present the raw data, but for the business it doesn't really matter. It doesn't really matter what is raw data, right? Ultimately, for a sales guy, okay, I'll keep repeating this multiple times, that for a sales guy, they're interested to know how many sales can I make next month, right? Based on that person, he or she will be able to plan the team, order the product, or request the development team to make the product available, things like that, right? So that's all. They don't care what data you're using, how you are using, what method, what model, what analysis you are doing, right? They just need that number. And when you say 500, they'll ask you why 500, how did you arrive at? And that's where you should be able to put all these numbers into a story format. Okay, so tables, and this is the basis where at least in logical terms, all the data is stored here. Okay, if data is not in table, you cannot access it. Okay, you cannot access it. And of course, we will learn how to create tables and design tables. That's the first thing. Next is your indexes. Okay, indexes are used to we can see, again, we are talking from database perspective, right? So what is more important is the reading capability, right? When you go and log into a website, let's say Amazon, and you search, you type laptops, okay, or 16 GB laptop. You type 16 GB laptop in the search. Now, when you click OK, how much time does it take for Amazon to display the record, right? You want it to happen immediately, right? You can't wait for 5 seconds or even 2 seconds for the results to come up, right? So indexes actually makes reading faster. Okay, so indexes are created on table to make accessing of data faster. Now, how do you visualize this? This is very much like, our textbooks, okay, have indexes, okay? How does, what's the purpose of textbooks having indexes? Same thing, you have 200, 500 pages textbook. It has a lot of information, right? But you don't know where to go and look for what. If you're reading from one to last page, it's fine. You don't need index, right? Because you're anyway reading from first to the last. Okay, so if you are accessing all the data in Amazon, doesn't matter. Okay, Amazon will be able to give you one by one. But when you are trying to access only laptop data, right? You are trying to access, let's say, a particular topic, right? So you don't know, where exactly in the book, okay, you have that particular topic. So what do? You go to the index, right? And index, look for the topic name. Okay. Now, why it is easier to look through the index? One, index will always be in a alphabetical order. Correct? Index will have information saved in alphabetical order, right? So if you're looking for say simplex method, just let's take an example of mathematics. Let's say simplex method. So it's like a dictionary, right? You go with S, then I, then M, and it says page number 299. Then directly you can go to page number 299. Yes, there is an extra time that is required to first find your topic name and then find the page. But overall, if you look at, it saves a lot of time. Okay, same concept has been brought to database. What it does is your table will have keys. Okay, so let's talk about keys now. Now, we all have some kind of unique number, right? Which can identify our identity. Like when you join a organization, they'll give you employee ID, right? What the purpose of employee ID? To uniquely identify you, right? Because if they start calling you by name, right, there will be multiple people with same name, right? There will be multiple people with the same name. So they try to give a unique number which can be accessed, right? In the US we have SSN number, right? Social Security number. The purpose of, one second, just give me a second. Okay, so if government wants to track your information using your social security number, they can track all your history, right? So similarly, every company, every body, every organization, they have a unique ID, okay, which is unique for everybody, correct? So in database also, every table will have a unique ID, okay, unique ID. So in terms of keys, okay, how do you arrive at the unique ID? Okay, so you have multiple keys like unique, primary key, composite key. Okay, so you have different types of keys, right? Now, the main here is primary key. Okay, primary key is that unique identifier. Okay, the unique ID, which will uniquely get the data. How do you create a primary key? Okay, so let's say you want to save employee information, right? So employee information, let's say you have name, you have date of birth, right? You have email ID, you have phone number, okay, apart from other things. Now, phone number can also be unique, right? Email ID can also be unique. Maybe name and DOB together can be unique. right? But phone number unique problem is that person can change their phone number. Email ID can be changed, right? And second thing is some people may not have email ID, right? Or, some people may not have phone number, right? You cannot force everybody to have phone number. Yeah, of course, everybody has, but you can't still force, right? Name and DOB, again, there could still be people with same name and DOB, very rare, but still, it's possibilities. So when you look at your data, right, when you organize the data in table, okay, the first thing that we do, okay, the first step that we do here, okay, let me put this here. The first thing that we do is we look for candidate key. Now, candidate keys are all the columns which you can convert into a primary key. Okay, primary key is that unique identifier, right, which will uniquely identify each record, each row. Okay, so all the possibilities, all the columns which can be created as a um, as a um, primary key, okay, will be actually selected and presented. Okay, from this we need to derive at primary key. You have to go through unique, composite key, and finally come up with a primary key. Okay, so we said that first look at the candidate keys. Okay, so candidate keys are all the keys, okay, all the values which are possible to be a key, right? So phone is also possible. Okay, email can also be key. Okay, name and DOB together can also be a key. Okay, so when more than one column, okay, together can form a key, they're called as composite key. Composite key means one column is not enough. You have more than one column. Okay, so this can be a composite key. This is your key. So we can have some kind of restrictions, or we call them as constraints in database language. Okay, constraints are the fact, or obviously the constraints or the conditions that you put on each column. Okay, constraints that you put on each column. So the first constraint you can put is called unique. Okay, now if somebody is giving you phone number, the phone number has to be unique, right? Let's say two employees cannot have same phone number. Okay, so unique means the value in that particular column has to be unique. Okay, like no value can repeat, or it can be null. No repetition, right? But it can have no repetition and can have null values. Okay, can have null values. It means that when you go to this one, either you have a unique number or you have null. Maybe that person doesn't use phone. So I can have 1, 2, 3 blank, 3, 2, 4. I cannot have 1, 2, 3 again. Okay, if you put, and these constraints are put when you design the table. That's why we're talking about in design spec. Okay, we're right. Focus is on design part. So when you create a table, first thing that you have to do is give rows and column. And this is assignment for today. Like we will not meeting for next 2 days, right? So assignment which I want to give is, think of a library management system and think of different tables it can have, and also add columns to those tables. Okay, so you can create an Excel file you can start, and like yesterday I did, right? You can have multiple tables in the same sheet. Okay, all the columns. Okay, all the columns. Second thing is constraints. Add constraints. See, whatever we discuss till today, try to use that knowledge only and create this assignment. Okay, so add constraints to columns as applicable or as you think about, okay, based on your understanding. Okay, then add data type. Okay, add data type to each column. We are not doing the SQL query yet. Okay, same whatever you are building now, same logic. We will first create ER diagram, then later we'll we use SQL to create table in our database. Okay, so think of a library management system. Think of how many tables you can create. Okay, what information or which columns should you add to those tables. Okay, any constraints that you need to add. Okay, data types. Also, we'll discuss data types before we go. And I'm not talking in terms of SQL or technical thing. You just have to put it in your Excel. Okay, and we'll do before we end. I'll just give you an example. And similarly, you have to build it. And last but not least, add at least 5 sample data to each table. Okay, if I have noted down so that I don't forget. So this is what try to do over the weekend. Okay, it shouldn't take much time. Maximum should take you is an hour. Okay, as much as you can. Okay, don't worry if it's correct or not. Okay, based on whatever your understanding is, try to do this. Okay, so coming back to our constraints discussion. So first constraint we said is unique, which can accept null, but if it has values, it has to be unique. It cannot, you cannot give duplicate values. Okay, so duplicate not allowed, but null values are allowed. You can have multiple null values. Null is nothing but blank. Okay, null means nothing. Okay, so it can be blank. Okay, so yeah, now then next constraint, okay, is your called not null. Okay, now not null, making sure values are added, and it does not talk about duplicate or not duplicate. It can be duplicate, right? So typically on email also you'll put probably unique, right? Phone also you'll probably put unique, right? On name, okay, you'll have not null. Okay, on name, not null is preferred. Okay, see, when you're entering somebody's data, you need to have name. Okay, a name can be duplicates. That's why I'm not saying it has to be unique. Okay, it can be not null. Then you can have other constraints like check, default. Okay, check is like let's say a salary. Okay, you have a salary field. Now salary field, let's say salary cannot be less than 1,000. Minimum is 1,000. Upward can be anything. So you can put a constraint saying check value greater than 1,000. So even if you enter by mistake less than 1,000, it will give you error saying violates. Okay, constraints. If you do not meet the constraint, message that you get is it violates. Violates not null constraint, violates unique constraint, violates check constraint, violates default constraint. There is no way. There is no. I mean, there's no way you can violate default constraint because we'll talk about it. But unique, not null, check. Okay, if you don't meet, it'll say violates. Okay, so if I try to enter data without name, it will say it violates not null constraint on name column. Okay, So, okay, so check, that's what, you can say value greater than, value less than, value not equal to, right? So those conditions you can give. Default, okay, is like if you do not enter a value, it will take this as a default value. Okay, mostly it happens like it's, let's say you run your business and 90% of your employee is sitting out of one location. Let's say you have office in particular city and 90% of your employee is based in that city. Now when you hire a new employee, right, 90% chance is that that person would belong to your head office, right? You might have sales people around the world, but all your back end support, product development, everybody sits in one location. So you can say when you design the table, you can say constraint default is New York, let's say, for example. Okay, so if you do not, so if you enter a value, it will take the value that you enter. If you enter Hyderabad, it will take Hyderabad. But if you do not enter Hyderabad value, if you leave it blank, it will add New York to it. Okay, because since 90% of employees are in one location, you don't want to type that particular location again and again, right? So you can make it as default. So these are your constraints: not null, unique, check, default. Okay, now there are some dependent constraint. Okay, we create this constraint based on the constraint that we have discussed. You have primary key and foreign key. We'll talk about it. These are keys, right? So these keys are created based on the constraint. Primary key means you can only create on the columns which are not null and unique. Okay, so when you say something as primary key, you don't have to say not null and unique. If you say primary key, it means that that particular column, okay, cannot have null values, cannot have duplicate values. It's a combination of not null and unique. Okay, so in this case, name, DOB together can be a primary key. Email can be a primary key. Phone can be a primary. No, phone is unique. So not null concept is not there. Email is also unique. Not null concept is not there. So these two cannot be primary key. Okay, not null and DOB together. DOB also, if you make it not null, most probably 90, I know there could very rare chance that, right, two people with exact same name and exact same date of birth, right? Not possible, right? In an organization, in the country, yes, but not in the organization, right? So possible that you can create these two as a primary key. But again, there are some consideration that you need to make. One first consideration is, while making primary key, make sure minimum number of columns are selected. Now, if you're in a situation where, for example, let's say you have this table, okay, somebody has created a lot of data and there's no way you can add an extra column. So in this case, you have no option but to go with name and DOB as a primary key. But that's not the recommended thing. Recommendation is try to use only one column as a primary key, okay, single column, right? Can you tell me why? See, any discussion comes about primary key, mostly we do for indexes. Okay, so so this discussion is about indexes. Okay, so when somebody is talking about index, keep two things in mind. Okay, one, speed. Okay, we have to improve the speed. Second thing, remember my example of book indexes. Okay, why do we add indexes in the book and what challenges it can be? Okay, so if you have two columns as indexes, that means if I need to know about simplex, I need to refer to indexes or two different set of indexes. Not a big deal, but it will unnecessarily waste your time, right? Already we have to go and look through the let's say simple example, a simplex. Okay, I want to look for word simplex. So simplex, I have to go through that index from A to Z and find the page number. Now, if I have to have two columns to look for, then I have to look for two columns. So let's say in first column, I get page number 5, 10, 15, 20, 25. And then I go for second column, it says 10, 20, 30, 40. Oh, you see 20 is common. So 20, the information will be on page number 20. Then you go. It is cumbersome, right? It takes time, right? Extra time. So if you have no option, if you have to watch if you have to refer to indexes, it's fine. I mean, nothing wrong, but it is only going to increase the access time. So that's why we prefer to have single column as index. Okay, that's the first reason. Okay, so preferably one, correct? And try to have integer or numeric column as your primary key. It is easy to, because I said, right, we have to refer like a key, right? Is A greater than, simplex means you have to see S greater than A, so it should be after A, right? So when you talk about number, you have only 10 digits to check, right? 0 to 9. But if you have alphabets, you have to check for 26 into 2, uppercase, lowercase, isn't it? It can become more complex. Now, again, this is a recommendation. Okay, your program will work fine even if you have 5 columns together. You can create a primary key. You can have date and text as a primary key value, okay, in that columns. But preferably, you should have a numeric and a single column. That's why we prefer to add, say, employee ID or book ID or transaction ID, okay? And most probably, if you look at, okay, it will be numbers, okay, not text, okay? So that's why we add an extra column, which will say, okay, we will make sure that this column is unique because it makes your accessing of data faster. Accessing of data is faster. Now, okay, any questions so far on the primary key? One unique thing about primary key is, okay, indexes for primary key is automatically created. The reason we add primary key is for searching purpose. Now, if you see employee ID, okay, has probably no meaning, okay, if you see in a way, because it's not going to affect you anyway, right? Your name is what is important to you. Your phone number is important to you. Employee ID, it doesn't matter whether it is 5-digit or 9-digit or it starts with A or starts with 5, doesn't matter, unless until you believe in numerology, right? So the reason we add primary key is for accessing. So the purpose is for accessing. So database says that, okay, let us create indexes by default on primary key. So that's why most of the time you might end up designing your database, but you may not even talk about indexes. You don't talk about indexes not because indexes are not important, but indexes are taken care automatically. Indexes are taken care about, automatically. So when you talk about performance tuning, again, we'll come back to it. First thing is indexes. Okay, many times customer claim that my accessing of my whatever table is slow. Okay, so it turns out to be that the most of the search is not done on the primary key but on different key. Okay, so let's say sales team, and they do a lot of calculations on bonus and bonus, right? Because based on how much sales they have made in last week, last month, etc., right? So they might look at values like how many sales, how many customers, how many new business, things like that. And employee ID in that case may not be relevant in that particular case where you're trying to calculate bonus. Now, if you are giving bonus to all the employees, then doesn't matter, right? But if you're giving to bonus to employees where You're looking at business they brought in, number of customers they spoke to, etc. Right? So in such cases, you are doing lot of search on sales, let's say. So if you're doing a lot of search on sales, sales by default will not have indexes, and it will slow down your search, the query. So in such cases, we will have to create index, and you will see the moment you create index, it runs super fast. Okay, there's a lot of difference you can see with index and not without index. Okay, so indexes are manually created on columns, okay, on non-primary key columns, on non-primary key columns also, if they are used primary columns also if they are used heavily, right? This is what I was trying to say. Okay, so if they are used heavily, okay, you create an index on it, okay, and your performance automatically improve. You don't have to do anything else. Okay, now coming back to our tables discussion. So this is what we discussed about primary key. So these are not null, unique. Select one column. If not, you add an extra column. Okay, it doesn't hurt, because the space versus speed, right? Speed is more important, right? Okay, and try to select numeric key as your primary key. Now, what is foreign key then? What is foreign key? We discussed yesterday, right? What is foreign key?
It's the primary key of another table, right?
Correct. So foreign key is the column that refers to another table's column. Okay, it's a link. Okay, it's a relationship. It's a relation. It's a link. Okay, okay, which joins your table with another table. Okay, so foreign key is the column in your current table, the table in which you are saying foreign key. And the moment you define foreign key, it'll ask you the query that we'll do later. It'll ask you that it should be linked to another table and another key. It'll ask you for two things: table name and the key. So when you say foreign key, you cannot just say foreign key. Okay, you have to say foreign key references table 1 column 1. Okay, again, it can reference multiple column, right? If you have two set of foreign key, it should match to the two. So it should be exact mapping. Okay, so another table's column, and most likely, most probably, it will be your primary key. Okay, primary key of other table. The key in other table. Not mandatory, but 99% it will be like that. Okay, so again, going back to our discussion here, and yesterday we discussed, right? So you have a table with books, and you have a table with members, right? Now I need to create a table which will track all the transactions in a library, right? So I call it as transaction. A transaction will have its own TID, transaction ID. 4, 5, 6. Okay. TID will have its own transaction ID. And here to link the transaction, okay, you can have BID and you can have MID. Okay. BID and MID. BID is your book ID. So here, if you have book ID and here you have MID. Now you see, you create this table, but if I don't say that my BID is a foreign key, it will not be linked. You have to say BID is my foreign key. So this is the column in transaction, okay, which is primary key in books table, right? This is what I said, okay. This is a foreign key. Here you will say foreign key, okay, but here it is a primary key. Okay, this is also your primary key. Okay, this is your foreign key. This is your foreign key, this is your foreign key, and this you have to say, you have to manually link it. Okay, when you're writing the query, create table, you have to say that BID refers to that. Now, there are a couple of advantages that you get. One big major advantage is that now your transaction table and books table are linked. Okay, so so when you have linkage, again, it has its own set of advantages, isn't it? First advantage is, now if let's say my book ID is empty and member ID is also empty, I cannot say BID1 and MID1, because when you create a foreign key, it will check if one is there here or not. One is not there. If there is no record of one, how can you have a sub record of one? It will fail. It says that, BID1 not found in parent table, right? So you need to have, ID here first. Okay, you need to have ID here first. Now you can link, after adding a member in the main table, only you can link in the transaction table. Obviously, if member is not registered with ID1, how can member 1 take transaction? Logically also it makes sense, isn't it? You need to have a member with ID1, only then the member can issue a book, right? You cannot say, I will give me the book today and I'll become member tomorrow, right? No, first you have to become member, you get a member ID, and only then you will be able to order the book in transaction table, right? So that's the one important aspect you have to remember, that the book ID has to be, or the primary key has to be created first, or as I said, right, 99% will be primary key, but it's not mandatory. It can be any table, any key, any column in that table. So the value should exist in the parent table, okay, parent column, before you can add a value to the child or the referenced. This is what we reference, and this is referenced, isn't it? Okay, so this is your foreign key. Okay, so when you create your assignment tables, try to include primary key, foreign key. Okay. Okay. Now we'll talk about different data types that you have in database, right? So again, what is the need of data types? Why do we need data types? So when you work on a column, when you work on any data, you need to know the type of the data, right? That will tell you what operations you can perform, right? If I tell you take two numbers, then you know that you can apply mathematical operations on that number, plus, minus, into, division, whatever, right? But if I tell you take two names, okay, and multiply the two names, you can't multiply two names, isn't it? Okay, so there are different types of data types which we'll discuss when we talk about the SQL. But for now, okay, just remember these data types. Sorry. First is your character or string, or you can say text. Now, SQL meaning has different. We'll talk about when we talk about SQL. Let's first understand these things. Then, as I said, right, we'll get into that. Character. Okay, character means text, name. Okay, would be character. Then you have date. Date value you will save as date. Then you have character, date, and number, of course, right? Numeric. Right? So these are three important data types. Number, like again, going back here, your EIP, employee ID, MID, BID, TID, all these are your numeric number, isn't it? Your name would be your character. Okay. DOB is your date of birth, date type. Okay. Email is again text. Phone number, you can decide, okay? I generally prefer as text because anyway, we are not going to add two phone numbers, right? So I generally use phone number as text only, okay? It should work. And of course, character has 3-4 types of characters. Your numeric has 3-4 types of numbers, okay? We'll discuss when we get into SQL. For now, just remember these are the data types: string or character, your numeric, your date, right? And you can even have binary. We call them binary. Okay, binary means two values. Okay, but these are the three main data types that we use. So when you design your table, use these data types only.
Swapnil, I have a question. How
Yes.
can phone number be text? Like it has
Why
to be
can't it be
numeric.
text? So give me a reason why it can't be text. It can be number. I agree to your point. But why can't it be text? See, as I told you, right? We the data type, okay, we assign based on what operations you want to perform. Correct? We are not going to perform any mathematical operations on phone number. Correct? We are not going to add two numbers. We are not going to say that my number is greater than your number, right? Right? So in that case, okay, giving a number, okay, would mean that you are handling a big size number, right? And unnecessary data, the database or the backend will be ready to perform those operations. Okay, so it is going to take a lot of it'll bring inefficiencies into the system. See, if I tell you, okay, um, um, come to office today and we'll go for lunch, versus come to office today and we'll have a lot of work. Now, the mentally when you are preparing, right, you will, so lunch, probably you don't even carry laptop. Okay, so let's say we are going for lunch as a team, so you don't even carry your laptop. But if I say we'll do a lot of work, you'll start thinking, okay, laptop I do need. Should I take notebook? Should I take pencil? Right? So your preparation changes, right? Depending upon what vacation you go for, right? Your preparation for each vacation is different. Mentally, you are preparing to handle those. Let's say if you're going to your family, okay, probably you may not carry a lot of dresses because you might have some dresses there. But when you're going out for a 1 week, you'll carry different. So my point is that here also, each when you decide which character or string, or and again when we get into the detailed discussion of data types, when we do our programming, you might have varchar, or numeric also you have short int, long int. Okay, short int means your size will not exceed more than 32,000. Long int means it can take million, billion number also. String, for example, if it is small text, it is fine. You can have blob, glob, right? Um, uh, so character, large object, glob, right? So sometimes you might have to define glob if you have GB of information. If you have to save entire content of a book into a single variable, then probably your character may not support it. You have to go for glob. So your preparation, okay, will differ. When I say numeric with 10 digits, okay, it is going to occupy a lot of space in the memory versus string of 10 digit. Because string of 10 digit, it knows that, okay, I'm not going to do plus, minus, into division. At max, you will do search, right? And very, very rarely you perform search on number. But yes, again, search is always better on numeric, right? So if you're designing your say hospital management system, where person comes and says, I forgot my PID, I forgot a patient ID. So they'll say, okay, give me your name, give me your phone number, and you're searching on phone number or name, right? So maybe in that case, you prefer to have phone number as numeric. So it depends, okay? My point is that you can also use it like a string, because mathematical operations we are not going to perform, okay? And we are going to perform same type of operations which you can perform on character also. Does that make sense?
Mm-hmm.
Yeah. Okay. Okay. So okay. So these are the data types that we have to use on when you are creating your columns. Okay. Can we extend for another 10 minutes? I have a couple of other topics to cover. Okay, as part of objects. We have only seen tables and indexes, right? We'll talk about 3 more important types, okay, or maybe 4 more. Okay, it's called sequences. Okay. Okay. Sequences is an auto auto generating numbers. Okay. Okay. So let's say for book ID, and you want to auto generate numbers. Okay. You want to auto generate book ID numbers. So you can create a sequence. You say that sequence starts from 1 and it has to increase by 1. You can define the step, and you can define very large number, go up to 1 million. So when you start creating or adding the values to that particular column, you don't have to remember what was my last PID. Let's say you have added some record today and you have values that PID took is up to 150. After a week you are adding one more record. So you'll have to first check what was the last value. Okay, 150. Now it has to be 151, and then you enter 151, right? So instead of that, when you say sequence, PID the sequence, okay, it will start automatically. You don't have to give the value for PID or BID or MID. Okay, you don't have to give the value automatically. Okay, it will add the value just like default. Okay, it will add the value if you leave it blank, but it will auto generate and add it. Okay, so if last value was 150, automatically it will add as 151. If last was 99, it will automatically add it as 100. So it saves a lot of time where you don't care if the system generates the number. Now maybe like you talk about SSN and other numbers. Okay, there's a logic that goes behind it, right? You look at state and location and various other things it looks at. Then they come up with that number. So in that case, auto generation may not be a good idea. Okay, but let's say employee ID. Employee ID, you want to start with employee number 1 to employee number, keep on increasing by 1. So it can be auto-generated number, right? So if you're right now your employee ID is 5002, next employee ID will automatically become 5003, right? So you can look at the situation, and based on that you can create auto sequence. So also when you're doing this, you can add this sequence that we can add sequence here in that particular column. Okay, so that's the advantage of using sequence. You don't have to think, okay, what was my last value? Otherwise, what happens if you don't know? You add 120 and let's say data is till 150. You add 120, it'll say primary key violation, right? Then oh, primary key violation means I'm using duplicate primary key. Then you add 130, again you get the same message. 139, again you get the same message. You do 200, fine, data will get entered. But 150 to 200, 50 numbers are which you could have added 50 more record is gone, right? So it avoids that kind of situation. Okay, then you have something called as views. Okay, so views are your logical table. Okay, data is in table only, as I said, right? But views, okay, they act like table, and if you have not created it, you will not be able to find difference between table and a view. Okay, the query, everything that we run is exactly like the way we do on a table. Okay, this is for various other purpose. Main purpose is giving certain access to somebody, right? Now let's say I have an employee record. An employee record might have everything: date of joining, previous salary, current salary, bonus, all those things. It will have 50 columns. Now, depending upon who should have access. Now, if somebody from HR has access, okay, to the table, probably you want to share salary details, but you may not want to share personal details. If somebody from non-HR department is trying to access the employee record, you may not even want to show them the salary details, right? So you can create multiple views on the same table. So when you add a record, when you add a new record, it goes to the employee table. But when you are viewing it, it is viewed on, you can say, employee birthdays, employee salary, employee something. You can create multiple views on the same table. So it's like this, okay? In presentation, right? When you make a presentation, right? You have notes at the bottom, correct? If I change the layout, okay, not layout, I think. Okay, so I might, okay, the notes here, right? So notes here, I can write my notes here for something, okay, for my reference, right? So what you see is only this. You don't see this when I make a full screen. So you will not see my notes, what I have. So this note I can refer before the class. Okay, I'll refer my notes. I'm ready, right? And I'll present the PPT. So you will see only this part, right? You will not see what is inside. So it's like this. This is like your table, and you create a view on it so that the user will only see the view. They don't see the underlying table. And this is very useful when you want to hide some column from some people. So don't give access to the entire table. Because if you give access to the entire table, they'll be able to see the entire record, right? So you say, okay, you create a view and then you give access to that view. So view is just a name, okay? The actual data is stored in the table itself. Then you have trigger. Now trigger are automatic. So these are code, okay, programs that we write to automatically do certain task. Now let's say you have let's say you have library, okay, and you have main librarian, and you have 3-4 department assistant librarian, okay, and these assistant librarian, they take care of each genre of book. Let's say that you have fiction, let's say simple fiction and non-fiction. So in the table you will enter the book name, all the details, and you'll have a column, say there you will have genre, right? You write fiction. If the book is fiction, you write fiction there. You can write a code on the table that if there is a change in this particular column, and the value is fiction, send message to so and so, or add entry in new table. So you are maintaining data in 2 different tables, okay, and in fact 3 different tables, right? You have one main table and you have 2 different tables, fiction, non-fiction. So you are entering, the first place to enter is your main table. After entering the data, automatically it should be added to either fiction or non-fiction, right? So trigger will do that. So so it needs condition, okay, and what condition the trigger should get fired? We call it firing the trigger. Okay, so trigger should get fired if value equals to fiction. Okay, and when it fires, what should it do? You'll write a query again. So trigger will fire when the condition is met, and it will do whatever it's supposed to do, right? So it can create another entry into a particular table using trigger. Okay, so when we start doing coding, we will do each of these things. I just want to introduce you so that when we talk about trigger, you know what we are trying to do there. And then last, okay, is synonyms. Okay, synonyms again. Synonyms are like another name that we give to the database object, mostly table, right? When you create a table, you want to give good names, not good name, I would say relevant names, so that developer would know, right? So for example, you are creating employee table. So you'll say employee underscore head office underscore something, but when you give this, when you share the same name with outside people, they might find it odd. One. Second, you might want to add some extra information in the table, okay, so that you know what this table is about, but you don't want outside world to know, right? So your actual table name could be something else, but you create a synonym. So synonym is another name that you're creating for an existing data. You can do for anything, okay, of view also. So you're creating a different name which you will share with the world. Okay, so when I say select data from employee, okay, because employee is what you told me, but internally employee could be the synonym for some other table. But for as a user, I will not even know that it's a different table. I will work and whatever I see is will be all like synonyms only. So sometimes you may not want to share the actual table name that you have created for a variety of reasons. You don't want to share a lot of information. It may not sound good. It may not look good. Okay, so you create a good name and then you say it's a synonym. Okay, so for now, triggered synonym views may not be important for the assignment, but you do work at table, data type, okay, constraints, including your indexes and maybe sequences also. Can you do it?
Yes, sir.
Yes. So please do that and we'll see you US Sunday, India Monday time, right?